Modern application development has followed along a thing called Agile, and you'll hear microservices. And an environment that has become very popular to run these modern applications are things called containers. We're going to take a look at various container options that we have available for us inside of the Azure infrastructure. We're going to look at the first of them, called an Azure Container Instance. My name is Bob Tickelman. I'm excited to be your guide for this module. Let's get into it. I'm going to spend a few minutes talking about the broad range of containers that we offer, and there's several different types. We're going to look at one of them in this module specifically, called container instances, and how they compare to virtual machines, as well as the other app service plans that was covered in a later module. We've also going to take a look at the broad range, and this is the only time I'm going to do it, but we have various types of containers. We have standalone containers. We have containers in a thing called container apps. We have containers that are part of an app service plan, and we have a full-blown container environment called Azure Kubernetes Services, or AKS. So we're going to take a look at an overall perspective of containers in general, as well as a specific implementation of them in Azure in container instances. When you take a look at modern application development, and this is not new, this has been around for several years, we've moved away from deploying operating systems to run applications. They were inefficient, and so we were having to have this huge overhead. Now, if I were to draw on this slide, if you were to take a look at an environment, there's still an OS here, and let's say that this is Windows. And you have the hypervisor. Now, Windows typically takes a minimum of 2 cores and 8 gigabytes. Some would say that's well under provisioned. I would say 4 and 16 is the bare minimum to run a Windows operating system. The hypervisor provided isolation so that you could have another Windows guest OS here, this one needing 2 cores and a minimum of 8 gigabytes, to then run your application. I've got another one here. It's got its 2 cores and it's 8 gigabytes just to run application B. Now, this worked really well when our applications were monolithic in style. You take a look at something like Exchange Server. You know, it needed 16 cores and 128 gigs of memory to run. So to have an underlying operating system that is only a couple of cores, it was balanced and it was worth it, the overhead to have. When we had things like SQL that took, many cores and many gigabytes of RAM to run, that worked out really well because it allowed the two applications to be separated. That way, if one of the applications became misbehaved, it didn't impact the other. I didn't have to restart operating systems impacting them. So in this case, though, when we start looking at microservices, the requirements for the resources and the applications themselves become much smaller, and it becomes disproportionate with a significant overhead to run the host operating systems virtually. This is where containers are anywhere from 6 to 10 times more efficient, because I still have my base operating system, but what you're doing is you're carving off protected memory and compute units from the underlying operating system without having to redeploy entire operating systems. So that is the value of containerization from a general perspective. Now, I also want to introduce a couple of terms to make sure that we get them used correctly. When we talk about containerization, there's 2 things we want to take a look at: the container itself and a thing called orchestration. The container is the environment that runs your application, and there's many products that are out there that do this. One of the products you might have heard of is called Docker. And for a period of time, it was the predominant player in this industry. It is the location in which your application ran in a thing called a Docker container. Now, the orchestration, and this will come out across the next several modules, you'll see this term. The orchestration, there's many companies that do this, of which Docker had a product called Swarm, so that you could manage your swarm of small containers using their product. But there is an industry standard that has become the dominant leader here, and it's called Kubernetes. Kubernetes is the capability to run any kind of container environment And so Kubernetes is the predominant leader. So I want to make sure that we understand the difference between, oh, I'm running Kubernetes. Well, that's the orchestration. What are you running from a container perspective? So we're focusing in this module on a container that has little or no orchestration. And as we move through these various stages over the next couple of modules, we're going to start to add orchestration in a certain component to a type of container. So the options that we have a container instance, where you're going to just get a container with no orchestration. There's no orchestration. We're going to have a thing called the container app. This is going to be in a separate module that you're going to get a container and you're going to get light orchestration. We're going to have an app service plan. Where you're going to be able to get a standalone container and the app service plan is going to provide the orchestration. And then finally, you're going to get what's called an AKS solution. We're not going to cover that in this course, where you're going to get a container and you're going to get Kubernetes as its orchestration component, full-blown Kubernetes. So that's the broad spectrum. This module is going to focus in on just this one and will be the only time that I talk about the overall components. So we know where this comes into play. We understand the difference between virtual machines versus container and the value that we get from containerization. And the industry has been moving that way for a long period of time and will continue to move. And I think more and more virtualization is going to become less and less of a picture. To do this, you need container images. And a container image comes from a repository of base virtual environments that you have. Now, there's public ones that are available. There's private ones. You can have your own. You can build your own. You can download other people's. So Docker themselves, and I'll do an example of this in the demonstration, has a listing of over 18,000 container examples. Do you want just a base operating system with nothing? Do you want something with Node? Do you want something with maybe MongoDB in it? So you can get a container that has the space carve out that is needed that will run on a Docker environment that has some or no additional software added to it. These images can be hosted, as I said, publicly, or we can push an image to an Azure Container Registry. It's an Azure service that can either be publicly or privately accessed from your container deployment scenarios that you're working with. We then go through a YAML file called a build process that will take an image from a container registry. It'll go to a code repository called a repo, where your code lives, which is equal to your app. And through this YAML build process, you will go grab an image, you will go get the code for the application, and you will deploy that application into a container, into a runtime environment. So that's the process, and so understand where container images come from as a deployment process that you want to work with. Are they yours? Are they someone else's? Are they privately available, publicly available? All sorts of decisions that you have around that. So the container instance becomes the deployment of a container and its corresponding code inside of an environment. And so what we have is this hierarchical structure. Now, the actual one's slightly different than what we have here. We have a container host, which is for all intents and purposes a virtual machine that might have something like, say, 24 cores and maybe 128 gigs of RAM. It could be a Windows, it could be a Linux box. It doesn't matter, and it's running some container product that's on it. Inside of that container host, we have, it's actually called a pod. You have a term called a pod, which is the allocation of resources. In this one, it might be 2 cores and let's say 8 gigs of RAM. Now, if you'd taken the previous module where we talked about app service plans, this is kind of like an app service plan, the pod. And the pod then contains one or more containers. Now, the vast majority of pods have one container in them. kind of like the vast majority of app service plans have one app service in the app service plan. So you're seeing almost a one-for-one relationship between app service plans using a legacy-based environment to deploy to Windows and Linux versus the container model. Very similar. We have the pod that has one or more containers in it that share the pod resources. That pod is deployed to a node, which is the actual name for it, that has the resources. This would be all intents as your virtual machine. And then what you get is a set of nodes that scales into a thing called a pool. So in a container instance, you're not getting the orchestration that falls along with the multiple containers in a pod, multiple pods in a node, and multiple nodes in a cluster. You're just going to get an environment where you can deploy a single container and not have to worry about any orchestration. But it can be used. It has an IP address that is now accessible by other portions of your application. They can be combined together from a management perspective into a thing called a container group, where you could have one or more containers or things like web apps that they get managed together, but it's not providing the level of orchestration that you would get from the traditional Kubernetes or other environments that we've taken a look at. So let's go take a look at the container instance as a simple way to deploy standalone containers with little or no orchestration. So we're looking specifically at container instances. I don't have any, so I'm going to create one, repeating a lot of what we've already done in other build processes. So you give your container instance a name, RJBT demo CI. Is there any availability zone requirements that we have? So if I want to put it into zone 1, zone 2, this is being managed by me, so I'm providing the orchestration for high availability. And then we get the SKUs. Where do I get my image from? So is it going to come from that container image registry? Is it going to come from a repository that I'm providing? Is it going to be an open registry? So I have to say where I'm going to get this image from. And then I can also use an image that comes from Microsoft. And so we have some pre-built Linux and Windows images that we'll have. In this case, you can see 2 cores and 2.5 gigs of memory that's going to be associated with it. I've got a series of other SKUs where I can come in and build what I specifically need, ranging up to 16 gigs of memory and up to 4 cores specifically. I then get the components of where I want to deploy this container. Again, I'm providing all the orchestration of where I want it deployed to communicate with other resources. And that's basically all you need to have to be able to deploy a standalone container. What is the image coming from? What is the repository where it's going to get the code to deploy into that container that you're working with? So a fairly straightforward, simple demonstration where you're not going to get a lot of orchestration. Let's return back to the presentation. So we saw the deployment of a standalone container that now allows me to use this modern method for deploying applications. It also ties into the current CI/CD pipeline standards that you're working with, as well as your microservice application development. We then move up the scale into the container apps. What you're now going to get is a lightly orchestrated container environment. You're still going to have a container registry that you can have one or more container images in, and through your build process, you can deploy multiple containers with the applications deployed inside of the same container environment. Now, this is a light Kubernetes environment from an orchestration perspective. It's partly masked. You're not going to have to do all of the clusters and all the node masters and all the stuff that comes along with an AKS solution, but they've made this very simple to now manage multiple containers through a lightly controlled Kubernetes environment that we call container apps. When you take a look at a container app versus an AKS solution, that would be the comparison. I would also maybe add on here is you get no orchestration, which is the container instance. But a container app, it says it's going to simplify the deployment and the management because you don't have to manage an entire Kubernetes solution. All the patching that comes along with Kubernetes, even the AKS, Microsoft takes some of that on for you, but it's going to provide now for the orchestration of a multi-container deployment. It's a platform as a service, and this is going to offer more control and orchestration and customization if you want to go to a full orchestrated model. Now, one of the nice things is maybe you're not ready to go to a full-blown AKS solution. You don't want to continue to develop your applications in that old method and using app service plans. What you could do, though, is you could move to container apps, not have to worry about learning the orchestration component, but start building and deploying your applications in this new modern method. At some point in time, once you've developed that skill significantly, you'll then have time and resources to say, gosh, I want to run these containers in a proper container environment. And that's when you might want to go to a full AKS solution without having to do anything differently to your app. Your app is already containerized. It now is going to be used to deploy and into containers that are managed by AKS as opposed to container apps. So I'm now going to go in and show you the difference when we go in and create a container app. So I'm going to come in and create my first container app. I have to pick up my subscription, the resource group I want to put it in. This is repeated from a lot of things, a name. I've got JBT container app. Where am I going to get my deployment for my container images? Is it going to come from a container image itself? Do I have a registry that I want to work with? And this is where we're going to start to build the container app environment, the hosted infrastructure, the servers that are platform as a service that Microsoft is going to deploy this on. So I can pick the region I want, and then I can pick my container app environment. Very similar to the app service plans, I could either have pre-built this and then selected it here if it was in US West, or I can build it at this time. So I'm actually going to create the environment. And so I can now have it zone redundant, yes or no. I then get into my workplace profiles. This would be very similar to, say, the node clusters when you go to an AKS solution to say, maybe I have a light workload. What do I want that light workload to be? So now I can pick the size or the SKU of the resources. So what is that underlying node infrastructure? It's only going to be, a lot of very small little containers. I don't need a lot of compute power being allocated to it. So I could say maybe a dedicated 4-core, 16 gigs of memory. I could have how many instances do I want? So I can now scale this to have it be a node pool that you're working with. So very simple to do this. And if you're familiar with an AKS solution, to go through and build this similar infrastructure will be a significant amount of work. I say add. I can have a heavy workload. Can come into something with 32 cores and 256 gig. Scaling up to more, maybe that's production. So I'm now going to build my node infrastructure. I can tie it to networking components that I want. Do I want public access to them? Is it going to be internal? So we've talked about in the networking module, is it a front-end web app that you're dealing with? Is it a business middle tier, so it doesn't need to be publicly available? Do I need load balancers in front of them? I'm just going to go through and create. Forgot to put that in. So where's it getting it from? From either Azure Container Registry or the Docker Hub. I want to go into a I don't have one in my own. I'm going to go to Docker. We don't need to see this build. That shows now a container environment and a container app where I can have more than one container, grabbing multiple container images from a registry and deploying them into a node infrastructure that we were able to easily configure. Let's return back to the presentation. So what you've now seen is 2 container options for you to be able to deploy this modern application environment. We saw that container instances, standalone containers to deploy. You can also have what we just showed, container apps that now have a lightly managed environment that mirrors a lot of what happened in the app service plans. So you can use either standalone containers, you could go to a container app, you're still going to need your container registries you're working with and the build process to deploy to them. We didn't show the ability to use the app service plans to host a container as well. That is an option I would encourage you to go take a look at to provide that traditional app deployment environment, but being able to use it for containers themselves. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.